All right, section 2.3, talking about biconditionals and definitions. So a biconditional statement is a single true conditional or a single true statement that combines a true conditional and a true converse. So remember that generally a conditional statement does not share the same truth value as its converse. But if you have a statement that is true in its original conditional form and its converse is also true, then that's a biconditional statement, and you can join it together by using the phrase if and only if. All right, and the shorthand for if and only if is IFF. All right, so take the conditional statement. If the sum of the measures of two angles is 180, then two angles are supplementary. Okay, of course that's true, right? We know that, yeah, if we have two angles that sum to 180, then the two angles are supplementary. So the converse of that is, start with the conclusion. If the two angles are supplementary, right, then now we go to the hypothesis. The sum of the measures of the angles is 180, right? And that's also true. Okay, so therefore, this is a biconditional statement. We can say two angles are supplementary, and then here's that phrase, if and only if. So that's the biconditional phrase. The sum of the two measures is 180, right? I did my colors backwards there. This should be blue. Okay. And you could say that either way, right? You could also say the sum of the two measures of the two angles is 180 if and only if the two angles are supplementary, right? So it actually goes both ways, where you can switch the hypothesis and conclusion. And the reason why is because, like we said, the original conditional is true and the converse is true. All right, and remember in the last video we talked about this notation where we have if P then Q with the arrow. So for a biconditional statement, we can use the double arrow. All right, so we just say, so this would say P if and only if Q. All right, so let's look at another biconditional. So here it says a point is a midpoint if and only if it divides a segment into two congruent segments. Okay, so a point is a midpoint if and only if it divides a segment into two congruent segments. So that means that if a point is a midpoint, it divides a segment into two congruent segments. And also, if a point divides a segment into two congruent segments, then the point is a midpoint. All right, so let's try this next part. Write a biconditional from this statement and its converse. So if a ray is an angle bisector, okay, if a ray is an angle bisector, there's our hypothesis, then it divides an angle into two congruent angles. So the converse would be, if a ray divides an angle into two congruent angles, then that ray is an angle bisector, right? And that's true. So therefore we can write the biconditional statement, and we can say a ray is an angle bisector if and only if okay, and you can write IFF if you want, if and only if it divides an angle into two congruent statements, two congruent angles, excuse me.